right, guys, so on worksheet 3, it starts to talk about symmetry. We are talking about tests for symmetry today and what different symmetries are called. So graphs of relations have two different types of symmetry. Graphs with line symmetry can be folded along a line so the two halves match. Graphs that have point symmetry can be rotated 180 degrees with regards to a point and appear to be unchanged. The three most common types of symmetry are shown below. So this is x-axis symmetry. What's weird about this? Yes, x-axis symmetry does not apply to a function. Okay, if it's symmetric about the x-axis, meaning you can put in y and opposite of y and get out the same value, there's the test. Okay, so like 2, 3, and 2, -3 are both part of the graph. Then, and here it says again, replace y with the opposite of y and it will produce equivalent equation. Okay, so this is x-axis symmetry. And the thing is, it's not a function. I think you have a little chart, and we'll fill that one in a second. I have it on a slide, but this is symmetry with the y-axis. So when you put in a negative x and a positive x, you get out the same y value. All right, so 2, 3, and -2, 3 give you out the same, are both part of the graph. This one is a function. Are you missing this worksheet? Oh, okay, you're good. And then the third one is the one that students kind of get confused about, but symmetric with a point, with that point being the origin, means if I took and turned this 180 degrees around the origin, it would look identical. So what happens is you replace the ordered pair x, y with the ordered pair opposite of x and opposite of y, and it's still a point on the function. So if this was 2, 3, then -2, -3 is also on the function. All right, so we have this little chart. Wait a minute, just kidding. So an even function is if it has, with respect to the y-axis, and an odd function is when it has respect to the symmetry with respect to the origin. Why isn't there a special name for x-axis symmetry? Not a function to begin with. Okay. So a graph of a relation is symmetric to the x and or y-axis, has line symmetry. A graph that is symmetric to the origin has point symmetry. Functions that are symmetric with respect to the y-axis are even functions. So I'm going to write they're called even functions. Okay. And for every point, you can replace x with the opposite of x. Okay, replacing x with the opposite of x. Functions that are symmetric with respect to the origin are odd functions. And for every x in the domain, when you take the opposite, you get the opposite on the y as well. This makes more sense down here. You replace x with -x and y, or the opposite of, and y with the opposite of y, and it produces an equivalent equation. I don't know what I meant by type of function. Oh, that's where I was supposed to write even, odd? I don't know. Okay, so this, I'm just going to draw a picture. This would be an x-axis symmetry, and it's not a function at all, right? So this would be an even function, and it has y-axis symmetry. And this is in a graph. Let's see, I'm going to do a different one than you already saw. Okay, assume that's not vertical at any point. Mine looks kind of vertical. But that would be an odd function. And let me use my tricky technology here to show you. The reason this is odd is if I turn it up 180 degrees, it's doing the same thing. Okay, do you see what's going on? Everybody looking? Okay, if I turn it 180 degrees, it's supposed to be the same shape. Mine is kind of not very regular, but all right. I will tell you that for this quiz, you don't really have to know the tests as much as to be able to look at the graph. Eventually, you may be asked a question where you have to test. So here are some examples. It says, this graph, negative x cubed plus 2x, and here's a picture. Analyze the graph to determine whether the function is even, odd, or neither. Confirm algebraically. If odd or even, describe the symmetry of the graph of the function. Okay. From the graph, it appears to be symmetric. How? With the origin? Okay. The test for that, here's our original function. The test for this is to replace this with a negative x, this with the opposite of x as well, and it should come out the opposite of the original function. So let's see what happens. If I replace this, there's a negative 1 out front that's already there. In place of the x, I'm going to write the opposite of x cubed plus 2 opposite of x. All right, what happens here? What is a negative x to the third going to do? Negative 1 times negative 1 times negative 1 is still negative, right? But there was that negative out front. And back here, this is just going to be a minus 2x. Okay, so this becomes 1x cubed minus 2x. So the question is this exactly the opposite of what we started with? Okay, here's what we started with. The opposite of that should be a positive x cubed minus 2x, which is what we got here. Okay. So replacing x, all of the x's with the opposite of x took the opposite of the entire function. So this was true. So the function is what when it has origin symmetry? It's odd. All right. So let's try this one. Even, odd, or neither. I might just try a standard window to start with. I might switch to zoom decimal just because it gets it in a little bit closer. What do you think, though? Even, odd, or neither? It looks kind of odd, yes? But is it? If I turn this 100 and... Oh, that didn't help. Let's see if I can... All right, just kidding. If I turn this 180 degrees, what happens? The intercept is different, right? Because it doesn't go through the origin. Yep. Yes, this is neither. Let me show you the test, okay? If we put in the opposite of x, we're supposed to get out the opposite of f of x. When I do this, I get a -1 x cubed. Everybody okay with that? So I have -4x cubed plus 1. But the opposite of this original function would have been -4x cubed minus 1, yes? I said to take all of this and do the opposite. So these are not equals, so it's not. It's neither. All right. What about this next one? You have a guess? Nobody's ready to start thinking about guesses? Some of you already typed it, probably. I think I'm going to need a window that goes up higher. Oh, it's not too bad, actually. I could do a zoom standard and then zoom out maybe a little bit. Yeah, I don't like that window either. All right, I changed my y's to -20 to 20, but what are you thinking? Anybody? Y-axis symmetry? Yes? Which makes it even? And what's the test? Does anybody remember? If it's y-axis, you actually change the opposite. So you change the opposite to on the x's. Okay, that's how I remember it. Y-axis symmetry means you can replace these with the opposite sign on the x's. So if I put a -1x in here and a -1x in here, it should turn out to be exactly what we started with. Does that work? -1 to the 4th is +1. -1 squared is +1. So the fact that we changed the sign to the opposite on the x's didn't do anything to the graph or the function. It turned out equal to what it started with. So we put an opposite on the x's and we still got back to the original function. Do you want to know the cheat? I would never rely on it if I were you, but this is x to what power back here, guys? X to the first would be x. X to the 0 is 1, yes? So there are 0 x's on this constant term. Is 0 an even or an odd number? It is even. So x to the 4th, x squared, x to the 0, all the powers are even. Okay? On this one, there was a 3 here, but this was an x to the 0, and that's an even and an odd exponent. So it was neither. Okay, once you have a fraction, you should be more careful. I think this one is going to be. What was it again? 5 over x to the 4th? Actually, a Zoom decimal might show this nicely. I'm not really sure. It's kind of hard to tell what's going on, but that's it, guys. It's just this little volcano graph. Do you remember ever seeing that before? Okay. So what are you thinking? If the graph looks like this, y-axis, which would be even, and to test that, we can, do you remember what the test is? Yeah, change the x to negative x. What's negative 1 to the 4th? Just 1, so it's back to x to the 4th. Okay. So replacing the x didn't do anything. Change, it kept the same, so it is even. All right, what about 9? Can you guess ahead of time? This is odd, and this is a power of 1, so those are both odd powers of x on there. So let's see what happens. I don't know where I got a 5. Can you see it in a standard window or not? Oh yeah. That's looking nice. Odd function with what kind of symmetry? What does odd function mean? Origin symmetry. Okay. What's the test? Do you remember the test? Yes, when you replace the x with the negative x, you get the opposite of the original function. In other words, you trade the x for negative x, you get out the opposite of y. So if I put that in here, negative 1x to the 3rd minus 6 times negative 1x, this becomes negative x cubed. This becomes what back here, guys? Plus 6x, okay? Is that the opposite of the original function? Yes? Change the sign on this and this. All right, what do you think on this one? Number 10? X-axis, y-axis, origin. Anybody awake out there? What do you think when you look at this one? Okay, if I have to turn the whole thing, it looks like. But if I turn the whole thing, is it still over here and like in quadrant 2 and 4, right? So it appears to be origin. What's the test for origin? Makes it an odd function. It said y equals negative 2 over x. If I replace both of those with an opposite, does it get back to what we started? If I switch the y over to the other side, you'd have this. So I did that one a little bit differently. I replaced both x and y with the opposite, and then I simplified, and it got back to what we started with. All right, what about 11? I eyeballed it and thought it was y-axis symmetry. Did anybody look at it and think that that was true? But it's negative 0.5x. Oh, this equation makes no sense. Do you see the equation they wrote? Yeah, it's totally doesn't make any sense for their picture. Okay, that's why I was like, I don't even know what this is. If it had been like positive 0.5x to the fourth minus 3, would that have looked like their graph maybe? Positive 0.5x to the fourth. Oh, there's this like minus 6. Okay. Let's see if we can fake it out by figuring out what their equation was here. Yeah, it might have been something like that. If it had been that, it would have been what? This would have been an even function. Okay, so the graph shows an even function. But what do you think about this equation right here? I'm thinking neither. Negative 0.5x to the fifth minus 3. And why is this neither? It kind of looks odd because it doesn't go through the origin, right? So if this had been the equation, it would have been neither. So that was just a bad question. That's not the only one. The book has some doozies. All right, so the only 4 questions you have about symmetry actually I think are 25, 29, and 39 on page 19 and 21. I think 47 is something different, but okay. Any questions about symmetry? All right. Worksheet 4, is that the one we're supposed to do next? I don't know why I'm on the last page. Okay. So worksheet 4, the only concept that we're going to talk about really today that's on the summative is this idea of continuity. End behavior and limits. We're going to talk very briefly about limits today, but it's not on a summative. There actually aren't limit questions until May. Okay. End behavior, we are going to have on a summative, but not this one. It's on the next one. So this is review. I don't even know if you have this. I think this is like a warm-up. But this is a concept that's on the quiz. What does this mean? F of negative 2. How do you do this given a picture? Yes, this is x value of negative 2. You look at the picture and you figure out what the y value is. They're using graph paper that counts by what again? 2's in both directions, so we get what? Negative 2. All right, f of negative 6 says if I were to go here, what's the y value? Is it negative 8? It's not included, I guess. That's icky. All right, what about f of 0? Also not included. Well, let's see if we can do one more that is included, because that was just not very fun. What is f of 6, guys? Here's 6, and it looks like the y value might be positive 2. What is this asking? Yes, this means if y equals 2, what's x? If y equals 2, x equals what? So that's saying if you go along the line y equals 2, what's the x value you're going to get out? Well, I kind of gave that one away a minute ago by doing it the other direction. This says if y is -6, that would be this line. Uh-oh, what happens? There's 2. Over here we get about, just say that's -5 maybe. And over here we get 7.5. I don't know. I'm just making something up. I think all you have to do is this kind of, well, not no solution, but this evaluate. What did I write up here? This makes no sense. What did I say that we got that? F of 6 was 2? Okay. I don't know why I wrote that way. Everybody all right? Remember how to find it, value? Okay. These are even, odd, or neither questions for some more practice. Do you want me to come back to this, or do you want to guess? Do you think you know without looking at the graph yet? This is an even exponent. That's an x to the first, right? And this is an x to the 0. So what are you predicting? Neither. What do you think about 63 over here? This is an odd number, but that's not what we're looking at. It's an n to the 0, right? Because it has no n. It is a parabola that's just a regular parabola that's been slid down 37. So what are you thinking? Even, which is y-axis symmetry. X to the 4th plus 6. Even. G to the 9th. Odd, it just looked like a cubic. What about here? Even. What about over here? 5, 3, and 1. Odd. 4, 3, I think we're already done, right? Okay, use the graph to confirm, but that's your hint. All right, which of the following is an even function? Can you look at those and see if you can pick out the even one? Which one? 6, 4, 2, and 0. All right, which of the following is the domain? Uh-oh. Okay, do you remember the rules? Domain is all real numbers unless what? Unless there's a denominator, which there is here. There's no radical, but there's a denominator. What do we do with the denominator? Cannot equal 0. What are we going to do with that mess? Take out an x. Does it factor further? No, so x can't be 0 or x can't be 16. Which of these is giving you the right domain for that? Why is it not G? Hard brackets, but it also says it can't be anything in between 0 and 16, right? And it actually can. All right. A continuous function has no breaks, holes, or gaps. You can trace a continuous function without lifting your pencil. One condition of a function to be continuous is that it must approach the same value, same y value from the left as it does from the right. Okay. Functions are not continuous, that are not continuous are called discontinuous. Graphs that are discontinuous can exhibit infinite discontinuity, jump discontinuity, or removable discontinuity. Okay, infinite discontinuity means there's a vertical asymptote. That makes sense? This is jump discontinuity, which would have to be usually some kind of a piecewise function, right? And this is a removable discontinuity or a hole. Do you remember doing some of those when you did rational functions? The good news is We will talk about these different kinds, but you will not have to identify which kind it is until you get to calculus, okay? We're just going to talk about them. The only thing you have to do for me is determine if something is continuous at a set value. I'm not going to talk about this very much. Here we go. If you had this, okay, it says what's happening at 2. Well, if I put a 2 in there, is this defined? 2 times the absolute value of 2 plus 3 is 7, okay? They go through this fancy process that involves limits to prove that it is continuous. They go 1.9, 1.99, 1.999, get closer and closer to 2, and it seems to be approaching 7, right? If they come from the other direction, 2.1, 2.01, 2.001, is this also getting closer and closer to 7? Okay, that's the idea of a limit that we'll talk about in May. Okay, so this has a limit at 2 of 7. All I'm going to ask you is it continuous? Is this continuous at 1? Look at this question right here. Can you put a 1 into that function? You'd get 2 over 1 minus 1. Can't do that, is right. So is this continuous at 1? No, there's something going on, either an asymptote or a hole. Okay? It's actually an asymptote, doesn't matter. They go through this big way of showing it. It says it makes the denominator 0, so it doesn't work. They try getting closer and closer to 1 from below and from above, and they're getting two totally different kinds of values. That's because what's happening at 1 is something like this. So it has an asymptote here, and the closer you get to 1 on that side, it's going down. The closer you get to 1 on this side, it's going up. All I'm going to ask you, is it continuous at 1? And you're going to say, no, so it's not in the domain. Does that seem okay? This kind of piecewise discontinuity is not on this week's quiz. It might eventually be on a quiz. The idea, guys, if I put a 2 in, do you see that this piece goes right up to 2 but doesn't equal 2, right? This piece starts at 2 and goes on. If I put a 2 in this function and this function, for it to be continuous, they should meet up at the same point. Do they? 2 times 2 plus 1 would be 5, yes? That would be an open circle, but it goes right up to that value, right? Here, if I put a 2 in, I get out what? 2 minus 1 is 1, and that would be a solid circle. So are they continuous? Are they at the same place? No. Let me talk about this in a way that makes more sense to you. We're going to graph these next week. 2x plus 1 starts at 1, goes up to and over 1, but you only get to keep the piece. Remember doing this and then you erase part of it? You only get to keep the piece that's greater than 2, so it would go like this. The rest of this dotted part would disappear. This function, x minus 1, is at negative 1 going up 1 and over 1. And you get to keep the piece that starts at 2, which would be 2, 1 here, and goes this way. So does the function at 2, is it continuous? No, it's really clear if you can graph it. It's not so clear when I talk about it, okay? But basically, if you put the 2, because 2 is a place where it changes rules, if they jump from one value to the other there, it's discontinuous. Oops, did you need me to talk more about that one? Or just give you a second? This one should be at 2, 1. I didn't do a very good job. This was the open circle at 2, 5. We will graph piecewise functions next week. All right. Is this continuous or discontinuous at 4? This is just a parabola. Is it discontinuous anywhere? No. Okay. If I put a 4 in there, I get 16 and 20 is 36, 39 or something. If I put in 3.999, I'd be close to 39. If I put 4.0001, I'd be close to 39. Okay. It's not doing anything. It's not got any breaks or anything. What about this one? At -4, yes or no? This is on 4B, guys. Why no? It makes the denominator 0, yes? Yeah, it's in the middle of 4B, I think is what he was trying to tell you. It doesn't. Oh, I think this was supposed to be like a, yeah, one of those guys, like a semicolon. That's what it's called. Okay, at -4, no, it's not continuous because it makes the denominator 0. Are you okay with that? Can I talk about this? Because what if I was tricky on a quiz and said, is this continuous at x equals 2? You get 0/6, which is 0. That's okay, right? You can have a 0 in the numerator, you just can't in the denominator. So this would be, yes, it's continuous at 2. This was, no, it's not continuous at x equals -4. All right, 2 more, and we're done for the day. Is this continuous at 1? No domain restrictions at all, right? Doesn't have a denominator. It doesn't have a square root. It's just a cubic doing something like this. Yeah. That's all it is, guys, on the quiz is a yes or no question. All right, number 8. Last one. Is this continuous at -1? Be careful. Maybe we should do what down here? Factor? How does the bottom factor? X plus 1, x plus 2. Anybody remember what that means when it has an x plus 1 in the numerator and denominator? It's got a hole. All right, so is this continuous at -1? No, because it makes both numerator and denominator 0. What about -2? No, because it makes the denominator 0, right? What if I said +1? That would be fine. To get continuous, they make it all complicated in the book. I just want to know, does it work? Is it part of the domain or not? For today, when we do piecewise, it's a little more complicated than that. All right, I did not assign, there are some problems on continuous in section 1.3, but if you think you have it, I wasn't going to put 1.3 on the homework check yet. Is that okay? All right, so due tomorrow on the homework check. No, Wednesday. I lied. Due Wednesday is worksheet 11, worksheet 7, like the circled or assigned problems. Worksheet 9 was circled problems. Then on your chapter 1 assignment sheet, it's the first 3 things listed, okay? The first 2 are both out of 1.1. It says Thursday?